Today we're going to be working on 203A. And we're going to be adding, subtracting, multiplying, and dividing functions. So you'll have something like f of x equals 3x, not 36x, 3x minus 5, and g of x will be x squared plus 2. And the instructions say perform f plus g of x, f minus g of x, f times g of x, and f over g of x. So the first one says add the two functions together. All you're going to do is combine like terms. So 3x minus 5 plus x squared plus 2. X squared has no like terms. 3x has no like terms. Negative 5 and positive 2 is minus 3. So this function's name is f plus g of x. Okay. Now, the interesting thing about this is if I plug in 1 to f of x, so f of 1, stick that in here, 3 times 1 is 3 minus 5 is negative 2. If I take that negative 2 and stick it in there, negative 2 squared is 4 plus 2 is 6. So I plugged in negative 1 and I got 6. If I plug in 1 here, I should jump straight to 6 if I did it correctly. So that didn't work. 1 squared plus 4 minus 3, that didn't work. Did I mess up somewhere? 3. So 3 times 1 is 3 minus 5 is negative 2. If I plug negative 2 in there, negative 2 times 2 is 4 plus 2 is 6. So if you plug in 2, why didn't that work? Oh no, I messed up somewhere. So forget I said that. No, it should work. Plug in 1. Oh, never mind. I did it wrong. If you plug in 1, I was thinking composing functions. Plug in 1 there and plug in 1 there and then add them together is the same thing as putting 1 in here. So negative 2, yeah, that one works. Okay, I was thinking composing functions. Okay, so for subtraction, and then the instructions say once you have your equation, you need to state the domain. So x squared plus 3x minus 3, what is the domain of this function? All real numbers or negative infinity to infinity. Why does it not miss places, I guess we would say? There are only 2 instances where the domain is shortened. What are they? When you square root a negative or when you divide by 0. So all polynomials have all real numbers as their domain. So for subtraction, you have to be a little bit more careful. 3x minus 5 minus x squared plus 2. How does that change things? We need to distribute the negative. So this is negative x squared and negative 2. So that would be negative x squared plus 3x minus 7. What's the domain of that function? All real numbers. If I take 2 functions and add them together, am I guaranteed to get a function? Yes. If you take 2 functions and you subtract them, are you guaranteed to get a function? Yes. So let's go to multiplication. So 3x minus 5 times x squared plus 2. So that's going to give me 3x to the third minus 5x squared plus 6x, or this one, minus 10. What's the domain of that function? all real numbers, because we don't have to worry about any dividing by 0 or squaring negatives. Um, what about dividing? So 3x minus 5 over x squared plus 2. Can I simplify that? No. What if it was x squared plus 5? Can I cancel the 5's? No. You have to factor them and cancel the factors. So what is the domain? Well, if I set the bottom equal to 0, and I subtract 2, x squared equals negative 2. What number for x makes that true? Well, if I square root, I get x equals plus or minus the I square root of 2. So it's not a real number. Is there any way to get a 0 in the denominator? If I plug in 1, 1 squared is 1 plus 2 is 3. If I plug in negative 1, negative 1 squared is still 1 plus 2 is 3. The smallest I can make this is by plugging in a 0. There is no way to make the denominator equal 0, because x squared plus 2 is a quadratic with no real roots. It never hits the x-axis. So that's still all real numbers. But I want you to look at number 8, or sorry, number 2. Let's start with number 2 on your worksheet. So looking at number 2, when I get to the divide, I will have 3x plus 2 over 2x minus 4. Is there a number that makes the bottom 0? Jason and Cannon? Set this equal to 0, add 4, divide 2. X is not allowed to be 2. So the domain is all real numbers, but x is not allowed to be 2. That's the only part of the domain that doesn't exist. Okay? Take a look at number 8. If I add those together, square root of x minus 1 plus 2x squared, can I combine those any further? No. What's the domain? Do we have to worry about dividing by 0? No. Do we have to worry about square rooting negatives? So, x minus 1, this stuff is not allowed to be negative. So this stuff cannot be less than 0. I'm going to add 1. X is not allowed to be less than 1. So the range, or the domain, is going to be not all real numbers, but x is everything from 1 to infinity. 1 is okay, because if I plug in 1, I get the square root of 0, which is 0. But if I plug in anything smaller than 1, then I end up with an imaginary number. If on number 8 we get to the divide problem, square root of x minus 1 over 2x squared. What's the domain of that? Some of you are working on the assignment. Stop, because you're going to miss this. What is the domain of this? Well, x is not allowed to be 0, because if x is 0, then the denominator is 0, and you get undefined. Okay? And x is not allowed to be less than 1. Now, it just so happens that this equals 0 also fits in with that, because 0 is less than 1. So we already knew this wouldn't work. But if I had something like this, square root of x plus 4 over x, this tells me that x must be greater than or equal to negative 4, and x is not allowed to be 0. So the domain for that piece would be from -4 to 0, union with 0 to infinity. Does that make sense? So the top cannot be less than -4, and the bottom is not allowed to be 0. So it's everything from -4 to infinity except 0, but in order to describe that, we have to use 2 intervals to make that work. Well, it's not all real numbers, because, yeah, everything over here is not there. And you can't say something like this. All real numbers, x to infinity, and x is not allowed to be 0. You can't really do that, because if you say this, you're only allowed to throw out individual numbers instead of whole sets of numbers. So you don't need this. And I guess technically you could write it like that, but I've never seen it that way. I've never seen anybody do it that way. Okay? What if, oh, they don't do it to you, but look at 19. No, it's not part of your set today, but for 19, the third power is really just the cubed root of x minus 4. What's the domain there? So, what is the domain of the cubed root of x minus 4? All real numbers. There's no way to create an I. Every number can be plugged in. And you can see that on the graph. A square root graph looks like this, whereas a cubed root graph looks like that. So cubed roots do have all real numbers in the domain, whereas a square root is limited by on one side. Okay? All right. Good luck.